10.6, we start dealing with polar coordinates. So the last lecture dealt with parametric mode on the calculator. Now we're going to be in polar mode on the calculator. Here is an ordered pair for a point in polar mode. You'll be given the r and the theta. So basically you are given the length, how far you are away from the center or the pole, and the direction in which to go. So r is that distance, and theta is the angle. So when you look at what you guys think normally of like XY axis, now
Yay!
so if you look at polar graph paper, they're the concentric circles. They just keep getting larger and larger, and I sometimes refer to them as rings. You know, it's the first ring, the second ring, the third ring, whatever. That's what polar coordinates are doing. So the center is called the pole. So the very center is called the pole, and this is called the polar axis, positive x-axis. So a few vocabulary things, but the big thing is remember that polar coordinates are r and theta. Okay? So if we go to a few of these points, find points on the polar coordinate system. We typically will give you these if you need to graph something. Maybe not on the homework always, but on the test or the non-calculator part. What do you notice that's different on this stuff than, say, the unit circle?
It has like the lines.
Has the lines, we have some more circles in there. What else?
Extra. As a 12.
Pi over 12 and 5 pi over 12. So basically they're really marking every 15 degrees then, right? Or every pi over 12 on this now. So just keep an eye on that. All right, so my suggestion is to find the angle first. So where's pi over 4? Pi over 4 would sit here. I usually do mark it with an arrow to show you guys where you're at. So that's the angle. Then after that, all you do is say, well, if the r value is positive, stay on that same side. If it was negative, you would flip across on that line to the other side. Since it's a positive 2, it's going to be right here. That's all it is.
So go on the second
Yep. So in other words, you're coming out from the center like you would the origin. You're coming out to the second ring, the second radius, and you are going to a direction of pi over 4.
So, what did you say about if I'm saying?
It would go the opposite direction. Instead of coming out towards pi over 4, it would have gone to the other side. We'll run into one of those in a second.
Would pi over 4 ever come before the 2?
No. It'll always be the r value first. Wait a second. So negative pi over 6. Where's negative pi over 6?
By pi over 6.
Same as 11 pi over 6. You're going to go from 0 or 360 and go down 30 degrees. And that's an r value of 3, so I'm going to stay on the same side. 1, 2, 3. There's my dot. Here's one with a negative r. Where's pi over 6? Right there. Pi over 6 is right here. But this time it's a negative 2. So instead of staying on the same side of the pole, the center, instead of staying on the same side, you flip to the other side. So now follow that line across. 1, 2, 3. 1, 2. Thank you. So you find the angle. If the r is positive, stay on that side of the circle. If it's negative, go to the other side. Just follow the line across and go to the other side. So quickly with somebody sitting near you, find -3, -2 pi over 3, and then we'll check your answer. I would first find -2 pi over 3. That's the same as 120 degrees going in the negative direction. So it'd be right over here at 4 pi over 3. Alright? So I'm at 4 pi over 3. That's that angle. Now, what does the -3 tell you to do? Go across to the other side and go to the third radius, third ring. So it'd be right there. So you should be in the first quadrant. Yes. Now, for every polar coordinate, for every dot on the polar graph, there are 4 representations. So what I'm going to do is go to pi over 3. Pi over 3 is right here. And we're going to go to the second ring, so I stay on the same side and I put a dot there. So that is 2 comma pi over 3. Now, that was starting at 0, going in the positive direction to pi over 3. How else could I get to that blue arrow by going in the negative direction? What is it? If I go all the way around in the negative direction. I heard somebody say it. What? -5 pi over 3 or -300 degrees. So, I don't care if you write down -5 pi over 3 or -300 degrees. For some of you, it might be easier to work in degree mode. Great. But if you now think about it, if you send somebody in the negative direction around to there, what do they have to use for an R value? Their location would be on the same side of the dot, so we stay with a +2. So right now, hopefully you can understand, we've done both positive R values, right? One that has a positive angle, one that has a negative angle. So positive angle to get to that location, negative angle to get to that location. Now, on the other side, follow the line all the way across, and it would be here where the red arrow is located. How can you get to that red arrow? What angle? You could use the -2 pi over 3, just like we did on our previous problem. -120. Okay, so if I go in the negative direction to here, what R value do we have to do? We have to flip to the other side of the pole, and we'd say -2. The easiest one, which I kind of figured we'd say first, is what? Is the actual angle that's right there. Going in the positive direction, which would be 4 pi over 3, or 240 degrees, I don't care which one you do. And again, that has to be a -R, because if you're over here, you want to flip to the other side of the pole. So those are the 4 representations. 2 positive R's, 2 negative R's, and then in each case there's a positive angle and a negative angle to each one of them. Any questions?
No, sir.